Indonesia, as a maritime country, has the ocean as a big part of our lives. First of all, it is used as a source of food, and second of all, it is used as an alternate water source. Third, it is used as aquaculture for production, and lastly, it's also used as a drinking water source for desalination.
But now, our sea is contaminated with heavy metals such as copper, lead, mercury, and many more. This will affect our ecosystem in a bad way, and it will create bioaccumulation, which will eventually harm us too. Therefore, the goal of this research is to create an alternative heavy metal adsorbent to help us clean our precious sea.
In this research, we would like to use zeolites, aluminosilicate minerals, used as an adsorbent for these heavy metals. And these zeolites can be found in beach sand, and it is called sodium silicate.
Therefore, the title of our research is the study of silica crystals as an adsorbent of copper and lead ions in seawater using beach sand as its base material. I'm Joanne.
And I'm Navina.
We're from Santa Lucia Senior High School presenting our research.
First of all, we would like to present you our research problem. First, composition. The composition, we would like to find whether or not beach sand contains sodium silicate used to adsorb these heavy metals. Second of all, we would like to test whether or not our sodium silicate is effective to adsorb the heavy metals.
The hypothesis of this research is the more amount of sodium silicate given to the copper and lead ion solution, the more effective the adsorbance of heavy metals ions. This will decrease more concentration of both heavy metal ions.
And in this research, we have our variables. Since we will be testing the effectivity, we would like to create 3 variants for our research. First being 0.2 grams, 0.5 grams, and also 1 gram of the sodium silicate treated into the copper and lead solution. Second of all, we would like to present our dependent variables. So from this, we would like to figure out or find the decrement of copper and lead ion concentrations using the adsorbance value to see the decrement. And in this research, we would like to set control variables. So from the sand taken from the same source and using the same method for each test, and the same type of metal ions of copper 2 and lead 2 is tested towards the silica crystals.
Throughout this research, a lot of purification will be done to transform beach sand into sodium silicate. First, the beach sand will be purified from its impurities using hydrochloric acid, and then silicon dioxide will be obtained from reacting the beach sand with sodium hydroxide. And then after that, we will get the sodium silicate by adding a few drops of sulfuric acid, which will create a gel-like structure, which is salicylic acid, which will then be dried and then reacted with sodium hydroxide again to produce the sodium silicate. After we get the product will be stirred into the lead and copper solution in a method called coagulation and flocculation, and then the adsorbance value will be obtained using a tool called spectrophotometry UV visible tube.
And this is our result of sodium silicate. So out of 100 grams of sand, we have obtained 109.2 grams of sodium silicate. That is 91% of the 120 grams of sand. And from that, we tested it through an organoleptic test. The color of our sodium silicate is white and the texture is powder. It is smooth and also dry and has no smell. From this research, we have obtained several data. So the first one is the decrement of copper ions. It can be seen that comparing 0.2 grams of sodium silicate given to the solution and then 0.5, the concentration of copper ions decreased by 27%. And then 0.5 gram compared to 1 gram, the concentration of copper ions decreased by 29.6%. And then moving on to the decrement of lead ions from 0.2 comparing with the 0.5 gram of sodium silicate given, the concentration of lead ions decreased by 49.5%, and then 0.5 compared to 1 gram
sea point at 8%. From these data, it can be seen that the sodium silicate is more effective to decrease the concentration of lead ions. How does this happen?
So an explanation is that the sodium silicate has a porous structure, meaning it has pores capable enabling it to absorb these heavy metals. And this is a diagram that shows the sizes of the two ions. The copper ions having 73 picometers and the lead ion having 119 picometers. So we can see that the lead ion's ionic size is larger compared to the copper loop. And from that, it has, we can conclude that the lead ions have a weaker electrostatic force. And with a weaker electrostatic force, meaning it has a weaker attraction with water. And from that, the particles of the lead ions move faster in the water, and therefore increases the probability of it being absorbed by the crystals.
In conclusion, sodium silicate crystal is an effective alternative to decrease the concentration of both copper and lead ions in seawater. This research is also very beneficial as the base material, which is beach sand, is unlimited and very easy to find. Other than that, all of the materials needed in this research are also easy to find. We don't need a lot of time to do this research, nor need a lot of spending.
We realize that our research needs further development, therefore we plan future works for our research. First of all, we would like to observe our crystals, our silica crystals, using the scanning electron microscope to observe the pores.
And then after that, we would use the particle size analyzer or PSA tool to see the actual size of the silica crystal.
And the sonic meter, we plan to create a nanoparticle product in hopes that it would increase the effectivity of the crystals in absorbing these heavy metals.
And then after that, we would also vary the types and the concentrations of the heavy metal used, and then also vary the contact time of the silica crystal and the heavy metals.
And last but not least, we would like to find ways that is possible for application for our ocean. So as proud Indonesian researchers, we would like to maximize the potential of